All right, welcome to your factoring review. So factoring is something we focused quite a bit on last year, and it's going to be relied on even more this year in Precalc. So we're going to review a couple of typical things you guys have seen with factoring, but also do a couple more complicated versions and learn some new strategies as well. So this factoring review packet will be an important tool for you, both on the homework and just moving forward if you need a review on factoring. So the first thing, there's kind of like a good order of steps to take when you're factoring. And the first one would be always look for something that you can factor out from each term in the expression you're looking at. And that's called the greatest common factor. So the first thing we're going to do is always take a step back and see if there is a greatest common factor, something you can factor out of everything. So greatest common factor. First, if you can do that, you will be able to simplify the factoring process after that. So looking at this example, 3x cubed plus 6x squared plus 15x, each of those terms have an x, and each of those terms is divisible by 3. So that means I can factor out a 3x, and out of the first term, that just leaves me with x squared. When I factor 3 out of 6x squared, or 3x out of 6x squared, I'm left with 2x. And then when I factor 3x out of 15x, I'm left with 5. So now I just have, once I've done that, now I have 3x times this quadratic that then I could continue factoring if possible. And as opposed to this cubic that looks like it would be too hard to factor, we can go ahead and take that greatest common factor out. So the next step, if there are only 2 terms in your factoring, obviously, again, check for a greatest common factor. If not, there's a really good chance that expression can be factored by a difference of squares, and difference of 2 squares. And this was something that we were introduced to in Math 3 last year. So it was a matter of looking at this example and saying, okay, 4x squared and 49y squared, those are both a difference, a perfect square, because I can square something and think about what I would square to get 4x squared, and think about what I would square to get 49y squared. So if I squared 2x, square that, multiply it by itself, I get 4x squared, and if I square 7y, I get 49y squared. So I first rewrite it as what am I squaring to get my actual difference of squares. And then the formula for that you've probably forgotten. However, I will remind you, and they're on the back of this page. The formula for a difference of squares is a squared minus b squared equals the product of a plus b times a minus b. Oops. And I'm not going to walk through how we discovered that last year. That was a specific lesson that we've done. We're kind of just moving forward to relying on memorization of these formulas. So that would mean when I factored this example, it would be, so this is my a, the 2x, and b would be the 7y. So this would factor to 2x plus 7y times 2x minus 7y. And that order can also be reversed, obviously. I could have written 2x minus 7y times 2x plus 7y. So this is a formula that you will be using a lot and need to be able to recognize. So when you are looking at something you're factoring with 2 terms, and especially if it's a minus in between, see if you can rewrite that as a difference of squares. The other thing is it may be a sum or difference of 2 cubes. And that's, I think, also something you guys were just introduced to in Math 3. It may have even been just an honors Math 3 topic. But again, this year, you're going to be relying on this formula. So the formula for sum and difference of cubes, it's a little more complicated than difference of squares, but I'm going to write out the formula for you first. Again, it's on the back of this as well. So if I have a sum or difference, it could be plus or minus. Let's just do, I'll do minus in this case, a cubed minus b cubed. Okay, the formula for this, there are two factors. The first one has two terms, and it's simply a and b, and I'll get to the signs, whether it's plus or minus in there in a minute. The second factor has three terms. Okay, so here's the pattern. Again, the first factor is just figure out what exactly you're cubing to get a cubed. In that case, it's just a. What am I cubing to get b cubed? B. So the first factor is just a and b themselves. The second factor, the first term is a squared, and the last term is b squared. So I'm going to start by writing that in. And then the middle term is the product of a times b. So that would be a times b in the middle. Now we need to figure out the signs. And that, the way that I was taught this and still teach it is the word SOAP, which is an acronym for same, opposite, always positive. So I will write that down. SOAP. Again, same, opposite, always positive, and I'll show you how that plays into this example. So same meaning whatever your original sign was it plus or minus? So if we had a difference of cubes, so same meaning it's going to remain the same, the first symbol. The next one is always opposite of whatever your original was, which was subtraction, so that would be addition right here. And then the last sign is always positive. So that's the pattern for difference of cubes. This is an important formula, and again, one that you are going to need to apply. So let's do this example down here. We have a cubed plus 27b cubed. So there are only two terms. That tips me off to check if it's a sum or difference of cubes or a difference of squares. Obviously it's cubed because I see a cubed and b cubed, and it's a sum. So now I'm going to apply that to the formula. Before I do, I want to first identify what am I cubing to get my two terms. So I'm cubing, what am I cubing to get my two terms? Obviously I'm cubing a to get a cubed, and then I'm cubing 3b to get 27b cubed. Now I'm going to apply it to this formula. So there's two factors here. One has two terms, one has three terms. So I'm going to write that in. I might run out of room here. Okay, so that would be my first term times my second term, and I'm definitely running out of space. Hold on here. Okay, and then my second one has three terms. And then let's go back to the pattern. So the first two here, I just need to identify what is the a and b, and I'm going to write those in. So the a is just a, and the second thing being cubed is 3b. So that's my first two. So a here and 3b here, my two values being cubed. Then on to this trinomial, which is three terms. The first and last are the squares of a and b. So that means it would be a squared, and then I would square my other value, which is 3b. So that term is going to be 9b squared. And then the middle term is the product of the two. So the product of a times 3b, which is 3ab. And then finally I apply SOAP. So same, opposite, always positive. So I had a sum of cubes, so that would be same, opposite, always positive. So this is my factored sum of cubes. All right, moving on. If there are three terms, we've got a couple of strategies for that as well. Okay. Bear with me. There we go. All right. So if there are three terms, we are, again, a couple of strategies. The first one is if it appears to be a perfect square trinomial. So let me write that and then I'll break down what that is. A perfect square trinomial. Now this strategy, if you can recognize a perfect square trinomial, will just make your factoring process a little bit quicker, but you don't have to. If you can't recognize it and you go to our next strategy, which is going to be area model and diamond game, that's fine too. But if you look at something and say, hey, that's a perfect square, my first term, and so is my last term, think about what that means when we're factoring this in terms of it being 2 factors times itself. These first 2 terms, this first one and these 2 first terms of each factor have to multiply to 4x squared, and the last 2 have to multiply to 25. So that tells us that because these are perfect squares, that means I can figure out what am I squaring to get each of these and plug it into this formula as a factoring of a perfect square trinomial, which is figure out what you square to get the first and last term. And those are your first and last terms of both factors. And then this middle term here will work itself out as long as we get the sign right. Now, since this is a subtraction, and this last one's positive, which is fine, because if both of these are negative, then my final product would be -5 times -5, which is positive 25. So again, this is just kind of like if you're able to recognize this perfect square trinomial, meaning the first and last terms are perfect squares, then it may factor to the square of a binomial, which means 2 terms. So that's just 2x minus 5 squared. If you don't recognize that, that's fine, because our next strategy will get us there even if we don't recognize that, which is using diamond game and area model. I didn't leave a ton of room here, did I? Diamond game, area model, area. And if it is factorable, then this is always going to work for us. So looking at this example, it is a quadratic. It's not a perfect square trinomial. 3 and 2 are not perfect squares. So at that point, I would start with this method to get that factored. So again, if I take, this is not a 1x squared, anytime that's not a 1, you take the product of the first and last, or a times c. So 3 times -2 is -6, which goes at the top of my top diamond. The bottom diamond is this middle term of -5, so -5 down here. And then I'm looking for those 2 values that multiply to -6 but add to -5. That would be, if it adds to -5, -3 and -2 add to -5, but those multiply to +6, so that won't work. So that means my 2 values would be -6 and +1. So -6 plus 1 adds to -5, and those 2 values multiply to -6. Once I figure out those 2 values, I can go over to my area model and fill in my first term here, 3x squared, my last term of -2 here, and then these values, -6 and 1, are going to break apart my -5x's, so -6x plus 1x. And then we figure out the length and width of this, so that we would have each of these areas. So because this is a 6 and I have a 3 here, I'm going to put the 3 down along this edge rather than this left edge, because if the 3 is down here, then I can multiply by 2 to get the -6. So I'm going to do that. So I'm going to have just x here, 3x here. 3x times -2 is -6x, and x times 1 is x. So then I have my factored form of this, which is 3x plus 1 times x minus 2. So that should be probably one of the things you're more comfortable with because we've done it so much, but still worth reviewing for those of you who maybe just need a little more practice with that. All right, this last strategy, you guys, I don't think we saw this last year. But this one's super valuable, and anytime I can almost, oh, come on, sorry. What is wrong with this? Okay. I'm just going to ignore the fact that these are overlapping up there because we're done with that problem, so we don't need it anymore. But if there are more than 3 terms, you are going to try to factor by grouping. And that's grouping groups of terms together that you can factor something out of. So, and I'll tell you now, if I give you something with 4 terms to factor, you are definitely going to be using this strategy, grouping. So looking at this example, I have 4 terms, and it's a cubic, and we haven't really spent a lot of time with cubics other than the sum or difference of cubes that we saw just a little bit ago. So if there are 4 terms, then your goal is to, instead of looking at this as all 4 terms, what can I factor out of all 4 of these? Well, I can't factor any single thing out of all 4 of them. But if I look at these first 2 terms, those both have an x. And these second 2 terms, those are both divisible by 4. So we will group them in that way. So these 2 terms, I'm going to group those because I could factor an x out of those. And I could factor a -4 out of these. And I'm specifically doing -4. And you'll see why in a minute. So let's see what happens now. So I'm going to factor these x's out. Actually, I can factor x squared out of those. So x squared, I pull out of just that first group. And when I factor x squared out of 2x cubed, I just have 2x remaining. And then when I factor x squared out of x squared, I just have 1 remaining. Okay, so I have just factored x squared out of each of those. Now I'm going to factor -4 out of each of these. And that would mean I have -4. And when I factor -4 out of -8x, that's just 2x, which is interesting because, again, look, I have a 2x here. And when I factor -4 out of -4, that's just 1. -4 divided by -4 is 1. Coincidentally, it's looking just like the result when I factored my first group of terms. So the goal of grouping is to separate them into 2 groups, factor what you can out of each of the 2 groups, and if you do it correctly, what you're going to find is that each of these 2 terms have another common factor of 2x plus 1. So now we're going to think of this as factoring this entire thing, 2x plus 1, out of both of those terms. So I'm going to take 2x plus 1 and factor it out of this whole first thing, and it leaves me with just x squared. And then I'm going to take 2x plus 1 and factor it out of this second term, and it leaves me with just -4. So I have factored, again, split it into 2 groups, factor each group separately, and if you do it correctly, you'll always result in, at least in these problems that you have with me, you'll result with these similar factors, same factors that you can then factor that out again. Now this, I actually result with a perfect square, so I could factor 1 more time in this problem because x squared minus 4 can be factored as x plus 2, x minus 2, because again, this is x squared minus 2 squared. That's a difference of squares. So I'm going to finish factoring this. It would end up being 2x plus 1 times x plus 2 times x minus 2. All right. Okay, so this last section here is just talking about how to factor completely. So that means if I say factor completely, there's a couple, options for what that even means. First, you could be factoring over the integers, which is what you guys are most familiar with, meaning when you're done factoring, you only have integers like 2x plus 1 times x minus 5. There's no fractions or decimals in there, which takes us to the next one, which is factoring over the rational numbers, kind of opening up the amount of possibilities, in which case you might have factors that look more like this: x minus 1/4 times x plus 1/4. If I had something that would be the same as x squared minus 1/16. So that factors as a difference of squares. We are not going to see a lot of this. So typically you're factoring over the integers. Eventually we will get to factoring over the reals. So I'm going to star A because that's one we're seeing. We're also going to be factoring over the real numbers. And factoring over real numbers means I can have integers, rationals, and irrational numbers. So factoring over the reals may result in factors that have irrational numbers, like square roots, x plus 3 times x minus 3, which is how I would factor x squared minus 3, which typically I would say is not a difference of squares because 3 is not a perfect square, unless I'm factoring over the real numbers, because 3 is a perfect square of the real number, the square root of 3. So we will get to this eventually, so you can just kind of tuck that away for now. Next is the complex numbers, which we will get to later on. And complex numbers have imaginary parts. So for example, 2x plus 3i. 2x minus 3i. So don't freak out. We will get to this at some point later this year, but for now we're factoring over integers and eventually reals. So, and then way later, complex numbers. So I'm just breaking down these different options you guys will see. All right, flip it over. Let's look at the back. And you see useful factoring formulas. So I've talked about all of these. I'm just going to review them. Difference of squares, if you have a squared minus b squared, then we see that formula. It's just a plus b times a minus b. Sum of squares cannot be factored over this set of reals. That's important. But it can be factored over complex numbers. We will get to this later. For now, difference of squares is a big one. Sum and difference of cubes, these are the same formula. Oh dear, hold on. Okay. All right, these are the same formula-ish. Sum of cubes, again, it's just figure out what you're cubing to get a cubed or in b cubed. Those are the first two terms. The first and last terms of the trinomial are a squared and b squared, and the second one is their product. And then again, apply SOAP, which is same, opposite, always positive. So that's the acronym SOAP and what that means. So SOAP. All right, same with difference of cubes. What are you cubing? Same pattern, you just change the signs. And then lastly, these squares of binomials. Again, you don't have to, this isn't necessarily something you need to memorize because you can, these are just quadratics. If you do recognize it, you may save yourself some time. If not, then you can just resort to the diamond game. I'm going to add that on here. Diamond game area model, because that is also another super important one that you guys will need to be able to use. So these three that I'm starring, you're going to be relying on a lot. So use these to practice the worksheets that are attached to this, and we can go over questions you have together. All right, y'all, that's it. See you soon.